So this is the content-based addressing that I was talking, and this is related to content-based addressing of hub-field networks. The advantage of content-based addressing is that retrieval is simple, merely requiring the controller to produce an approximation to a part of stored data, which is then compared to memory. However, not all problems are well suited for content-based addressing. But content-based addressing is more general than location-based addressing. And focusing by content, as I said, we have a cosine similarity K here. It says what is the similarity between your key in each of those memories. Because for each I, we have a different similarity. The similarity, for example, for each I, we want to know which key is and beta is the key strength. And by focusing on location, it means that we want to, each head emits a scalar interpolation gate, G of t, in the range between 0 and 1, and the value is used to blend between the weighting Wt minus 1 and Wt. So going from two different extremes. Depending on G of t, you could be anywhere. And focusing by location, if the gate is 0, then the content weight addressing is entirely ignored, and the weighting from the previous time step is used. If we index the n memory locations, the rotation applied can be expressed as the following circular convolution. So the combined addressing is a system of weighting interpolation and content and location-based addressing can operate in three complementary modes. 1. A weighting can be chosen by content system without any modification by the location system. 2. A weighting produced by the content addressing system can be chosen and then shifted. This allows the focus to jump to a location next to, but not on an address accessed by the content. The neural Turing machine architecture describes as several free parameters, including size of memory, the number of read and write heads, the range of allowed location shifts. But perhaps the most significant architectural choice is the type of neural network used as the controller. In particular, one has to decide whether to use a recurrent or feed-forward network. A recurrent controller such as LSTM has its own internal memory. Well, I've explained all of them. So the experiment that they said is copy task. It's very simple. We just copy. And you see that LSTM has a higher cost because this is for LSTM. You see it's higher cost. For example, at a given sequence number, you see that the LSTM has higher cost than NTM with LSTM. But NTM anyway is much better. It has lower costs. And because it's a bunch of 0 and 1, just like firing or not firing of neurons in your brain, we have 0 and 1 in different locations. So we have, as time passes, you go to different locations for both write and read. But for me, Hopfield network and modern Hopfield network are more interesting than the approach of this article, which is done by human.